Okay, so now let's go over this point here. It says abstract method or function cannot be contained in a non-abstract class, right? Um, so that means that inside your non-abstract class, like for example in this case, inside the main program, as well as the triangle and then the rectangle class, these are not abstract classes, right? So what that means is I cannot have something like this in there. Okay, it has you cannot put that in there. So it's like in the triangle class. Okay, I cannot go in here and create a new class, new function with the keyword abstract. Maybe like a double get volume, right? Okay, you cannot do that here because this is not an abstract class. So you cannot have an abstract method inside a non-abstract class. Okay, so that's all it is. If you want to do that, then you have to convert this to an abstract class. Okay, so only abstract class can contain abstract method. Okay, that is the rule. So if you do this, and then it's all good, right? It's still fine. So or may not be fine, because if I save this, you see it has a red X here. Why? What do you think why is the problem here? And it tells you right here. Why is that? Mm-hmm. Yes, exactly, right? Because now it's an abstract class. Even though it has all these functions in here, these are not abstract methods. But because it's abstract class, now the same rule applies to the shape, right? So it cannot instantiate a triangle because triangle is abstract. So how do you use triangle? Well, you have to create another subclass to extend the triangle class. So
create another subclass off of the abstract class triangle, does that one also then have to have those same parameters that the triangle one?
Like the shape has these.
So like the shape, you have the get area, get parameter has to be in the triangle.
It doesn't have to be. If this is the only a class that is extends the shape class, then yes. If there's a third one, we just show you, right? If there's a third one called right triangle that extends that triangle class, then that class can do it, or this class, either one, it's fine. Okay. So yeah, right. So if you take this out, then again, it's gonna well, because right now it's expecting a child class to implement the shape class. But yes, you will have to do it somewhere, either inside here or another subclass of this class. Okay, so you have to do it somewhere. You cannot leave it out. So, yep.
So if you extended rectangle, would that satisfy that? And you just had get area in rectangle, but not in triangle, then
you may extend it here, or I'm not sure what you mean.
Yeah, like in the rectangle class, you extend shapes. So that doesn't, you can't just have it in rectangle. It has to be in triangle and rectangle.
You mean like the shape? I'm not sure what you mean.
Well, you're saying like if in triangle, it has to have get area.
Oh, the get area?
Because it's in shape, right?
Yes.
Or it has to be in a child class of triangle. So
yes.
the fact that you've got get area and rectangle doesn't matter.
Right. So that means if I like you say, for example, if you extend the triangle here, right? Like you said, I'm not sure what you mean or not, but if I do this, and then right. So if I do this, then it'll work. But then now it says I have to implement the get volume because triangle has an abstract. I just created one called get volume. So now it has to do, it needs to implement that inside the rectangle.
Okay, I see.
Okay, so it's like you fall down the tree. So one of those child classes has to implement one of those methods or all of them. It doesn't matter where it is. Okay. But if I do like this, then of course we have two separate objects, and they are completely separate entities, but they're also points to the same shape. Whereas if I do this way, then rectangle is the child of the triangle, is the child of the shape, and so on. Okay. So in other words, if I do this way, then right inside here, I don't have to do that, right? See, I don't have to implement that. It's fine. And the rectangle, see, it's okay, right? But now I have a problem because now I cannot instantiate triangle because triangle is a abstract class, and so I can only do the rectangle, which is fine. So the shape is the parent, the triangle is the child, and then the rectangle is the sub-child or the child that. So you have 3 generations going on. Okay. So I'm going to put this back to what it was before. So that's basically what it means. It's saying you cannot have an abstract method if the class is not abstract. Okay, so that's what I wanted to point that out. But if it's an abstract class, then you can have both an abstract method and a regular, just your normal method in here. Okay, you could have like public, maybe, you can have like double get volume, right? And then you can do the volume in here, return maybe just say 12, for example. Okay, so you can have your regular method in here. You could have your private, double t, whatever it is, here, and then maybe return t for volume, for example, or v, however you do it. Right, so you look just like a regular class. And you don't have to have these either. You don't have to have an abstract method either to qualify it as an abstract class. Okay, it's not required. You can. Typically, you want to have it. I mean, that's why that's a reason for the abstract class, right? But you don't have to have an abstract method here to be qualified as an abstract class. Okay, the class can be an empty. It's fine. Well, I mean, there's no point for that, but you can. So, so now because we have the t here, the get volume, and then now in my program, and the main program here, you can actually get the volume as well. You can do like t dot get volume because t is the child of that object, of that class, right? So you can get all those methods. Everything inside the shape class can be accessed by all its child classes. Okay. And if you have this get volume inside the triangle, then of course what happened here? We're actually overloading, right? Overriding the parent again, same thing. So I don't have t here. We should say 23. Then when you call it this way, then this t get volume is actually calling this local one here and not the one in the shape, because it finds the closest one first, right? It finds it first inside the class. If it has it, use that. If it doesn't have it, then we'll look up into the parent class and then get it from there. Okay, so that's how these are traversed. All right, so that is oops, put that back in here for now, and let me remove this back. Okay, so what that means. Same thing. These two means the same thing. A class cannot can contain methods, but must be abstract, right? If you have an abstract method, then this class must be abstract. So a subclass, even subclass, does not implement all. Okay, all, like I mentioned many times. If you have 3 methods, they are called abstract. Then the subclass needs to implement all of them. It should say a subclass, or maybe in this case, it doesn't really tell you, how deep down is the tree. It could be a couple layers down. But as long as one of those subclasses implements the inherited abstract methods, then that's fine. Okay. But all of those has to be implemented somewhere by somebody, right? And then the abstract class, a subclass can be abstract, even if the superclass is not. Okay? So what that means is, here we have a triangle class, which is not an abstract, right? And I had a right triangle class here earlier. So this right triangle extends the triangle class, and this triangle is a right triangle is a subclass of that, but this could be an abstract class. Okay? And it should still be fine. All right? So you can have abstract, concrete, abstract is okay. You can have abstract, 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 concrete is fine. Okay? So it doesn't matter how you do it. In any order is fine. Just remember that if you create an abstract class, you cannot create an object right off the right triangle here. Okay? So I cannot do like again, same rule, right triangle. RT is equal to new right triangle. You cannot do that, right? Because it's an abstract class. So now how do you get to the right triangle? Well, we have to have another class that would extend that right triangle class. It would be a concrete class to do that. And maybe you could have like the main program could extend the right triangle. Right? So we do that, then instead of right triangle, I could just say main program. So now it's happy. Okay? As long as one of those child classes is a concrete class, then that's fine. Okay? Are we good with this? I know it's convoluted, but you can see how you can move up and down, you arrange all these different methods around to make all this work. So now I'm going to show you why is it important to have the shape class and use these two get area here for the triangle and the rectangle. I mean, I could just do this, and I can still print out the area here, and it's fine. One thing that the book mentioned is in the chapter here. I'm going to show you right below, like right down here. It has another function to compare the volume of those two classes. So right here it has a function called equal area. Okay, so it compares the object one, like the triangle and the rectangle. It compares their areas, whether they're equal or not. Okay, so we could do something like that in the class here. So in the main program, I'm going to write another method down here, which is similar to the one in the book. So public static, it's a Boolean type, return is equal or not. Just say equal area, and I'm going to compare the triangle and the rectangle. So it has to be the same type, right? So triangle T, and then the rectangle R. Compare those two, and there are objects, right? So I need to return is the object T dot get area. So the area is, in this case, it was I forgot, it's like 2 or something, right, for the triangle. Is this area equal to the area of the rectangle? If they're equal, then it returns true, otherwise it returns false. So this function only compares those two areas, those two objects, right? And then down here, we'll write a third line here, just to say the area of T and R, and just put like true or false. It will be just true or false. If I say equal area, I'm going to pass in T and R. Okay, so it will return true or false. It's a Boolean type. If they're equal, you get true. If it's not equal, you get false. Okay. So I'm going to, well, yeah, leave it as it is, fine. Okay, so let's save this. Let's save everything. And then I'm going to run it now. Alright, so you see that they're not equal, it's false, because the area of a triangle is 2, and the area of the rectangle is 4, and they're not equal, so therefore it's false. Right? If you want to make it equal, just to test it out, then we can change the area here to be what? 0.5, right? 0.5 to be equal to 2. So 0.5, right? So 0.5 times 4, I think it's 2. Okay, so let's run it again. Oh, no, now 0.5. What is it? 1. The area of the triangle, rectangle. 1, 2. Yeah, 1 times 2, right? Okay. No. Was 0.5?
No.
Was the area of a 1, 2, right? Yeah, that's right. It is the base times height, so it's 2 times 1. Yay! That's a tough one. Yep. Okay, so we compare. The area of triangle is 2 and the area of rectangle is 2, so they are equal, so therefore it's true, right? We compare those two. Okay. Now, what if you have a third shape you want to compare? A circle. What about a diamond shape or octagon? Right? How do you do that? So that means you have to have different function to do all that, because the parameter will be different, right? This is only for triangle, this is only rectangle, and then you have one for a circle. You have to have a different method because it's a different type. Okay, so you can see that you can have a problem here because of this different type. So and I can compare the areas because there are separate objects this way, and even if they don't extend the shape class, even if I do this for that triangle, I'm not overriding that. Okay, so even if I don't extend that shape, make those just regular methods classes, and of course this will not be right. Let me just turn this off. Okay, if I do that, then everything should still be fine. I can still get the same volume. Everything will just like it was before. Okay, I can still compare the areas, and then because I'm passing the two different objects, the T triangle and rectangle, compare the areas. Okay, so you can see that that's fine. And then if I did like I did before, so you might wondering like, why would you do that? I mean, what's the point anyway? If I can do that using the regular normal way, why would you need a third class called shape to do that, right? And the reason is because of this. Again, if you had this object, it grows. You have a lot of different shapes. That's not efficient. So instead of doing that, you would do something like shape, and then make this into an array. Okay. And then the array will be comprised of T and R. Okay. Because they are the child class of the shape, therefore the type shape can take the triangle, the rectangle, you have a circle, you have the octagon, and all kinds of shape can be inside the array of S. Okay, so now if I do this, I can now easily modify my code here to have just one object called shape of type array, and I call it S, and then I would just put S of 0, sub 0, which is the triangle, S sub 1. I can compare their volume, their just put S in here. Okay, and as you can see, it works just fine, right? So if I have a third object added here, then all I have to do is I could have another rectangle, right? Rectangle here, call it R2, and it has a different, maybe a different value for R2 here. So it doesn't matter how big this object S is, the array is. All I'm passing is the array to this function here, and in here I can do any of these data manipulation without worrying about, oh, I have to have a different method because I have this different shape, a different object inside that method. Okay. And so now because they are the same they share the same parent class, I can compare their the areas, and because the areas, the get area, are part of the shape, they all share that. It's just that each of those has their own implementations. Okay. So this method, the get area, get parameter, has to be a part of the shape class. If I have, let's just say in triangle, if I have, let's just say another method in here, let's see if that works. If I have like public int, just do something here. I'll just call it get int. Doesn't matter, right? And then return, let's just say 5. I'll copy the same one over to the rectangle. If you notice, these are not methods inside the shape, inside their own individual methods in here. Okay. So now, so this one only applies to the triangle. It does not exist in the shape. Same thing for the rectangle. What if now I want to compare the shape? I mean the get int. Right? As you notice, you cannot access the int, the get int method here, because the triangle and the rectangle, they have access to their own method called get int, but because it's not part of the shape object, which is the broader class, so this class cannot reach inside the triangle and the the rectangle to compare their data, because this S is of shape type. So to make it work, you have to have this method inside the shape, and then you make this an abstract. And then again, we're back to the same thing here. So now in the program, it's all happy and it's all good. Okay, so I can do that, to get in from that one, to get in from the other class, and then everybody's happy, and then we're back to where we were before. Okay? So that's the reason why you do this way, because you can have so many different objects here. In order to compare their data, like you have like 10 cars of type car. You have planes. You have other objects that are related to vehicles. How do you compare the speed? How do you get the engine type, right? How do you do that? Well, if I have 10 cars, that means I have to pass it 10 times in here to compare each of those individually. Whereas if you put into an object of an array of the broader shape type, then you can compare, just pass one object along, and you can get those data, compare them easily. Okay?
You
So
think of shape as a data type,
yes,
and that always helps, I think.
yes,
Like
it's right.
int is a data type,
Yes, it's a data type.
or double is a data type.
Mm-hmm.
Now shape.
Now
is a
shape.
data type.
Yep. That's it. Okay, so are we clear with the abstract class now and the concrete class? Okay, so the last 10 minutes, really easy, shortly, the interface class, or the interface, is very similar to abstract. Okay, it works exactly like abstract. Only difference is, well, there's actually like a few little differences. So in the interfaces, you have some rules here again. So here you cannot have any variables allowed. If you do have them, they must be constant. Okay, like the word final. Okay, whereas in the regular abstract class, I have a double T. It's not final. Okay, so it says you must be constant. That's a final. So it can only contain constants and abstract methods. So that means I cannot have something like this. I cannot implement a method here. So all it has is a bunch of fields and a construct. It doesn't have constructor either. Cannot have a constructor. So just have fields and abstract methods, method heads, declaration. That's all you can have inside the interface. So it's much broader than an abstract. It's really broad. Okay. So if you think of like what is broader than shape, well, maybe I don't know what's above shape.
Metaphysics.
Yeah, something above shape. I don't know what that is. So if you think of something like that, then that's usually what it is. It's an interface. Interface. If you think of like a physical object, would be like the interface for your computer here is like how do you plug into your computer? All these things interface, right? How you plug it in. It's really broad. What happens inside is the black box. Okay. So interface is how you connect to something, right? So, so that's that. You cannot create instances, again, just like the abstract. You cannot use the new to create a new object out of that. Okay. The interfaces must be public. Okay, or I have to use the abstract modifier, and then you have to use the right. So they all have to be public. So here's the difference. So let's go and create a new I don't know, what do you call it now? Let's just say I could use something similar to the one in the book. So say geometric. Okay. Bless you. So for now, I'm gonna say So, okay. So I'm going to turn this to an interface. So can I have the word class in here? Okay, so the class will be replaced with the word interface. Okay. So as long as you make this interface, you can no longer have a constructor. Okay, so you cannot have constructor. That has to be taken out. Okay, this one here has to be public. You cannot set it to private. Okay, it cannot be a private. Has to be public or abstract. Okay, and I think that still be fine. But usually it's public. So it's always public. If I can spell it correctly. Okay, it can have only fields, like for example, you would just say string name. I cannot have like private string name like this, whereas in the abstract you can, right? I could say private string, and you leave it blank is fine. Name, right? And that's fine. You have, but in an interface you cannot have that. It has to be a constant. So this has to be final. Not only that, because it's final, you have to have a variable with data, right? They have to have data. And then now, you cannot have private, it has to be public. Okay? So a lot of rules for interface, but basically, it has to be public only. You cannot have it private. Because, I mean, what's the good use of an interface if it's private? Okay? You can plug it in. I mean, if there's a internal plug inside here, you can't see it. What's the point, right? So it has to be public.
What if you set that to null?
Here?
Yeah.
Yeah, that should be fine, I think. Is it null? String.
Yeah, I don't think Java will let you do that.
Yeah, no, yeah, it doesn't take it for string. Not null. Because null is, yeah. Can we do that in the shape?
Probably you can do it here, but
Yeah.
not in there.
Or did I mistype it? Yeah. Oh yeah, it should be fine.
Oh.
Yeah, I had to capitalize. I mean, as long as the value is fine. You cannot leave it on because typically if you don't put it like in here, right? If you don't explicitly say it, write it down, then implicitly it will say no. It will assign a value of no anyway.
Yeah.
But in the interface, you have to supply it, even if it's null. Okay, so you have to put a name in there or a value. If it's an integer, it has to be an integer and so on. So that's rule number one. So if you want to have a method in here, it has to be public. It has to be abstract. You cannot just say like we have here in the shape here. We can have abstract method here. You have a regular method without any abstract keyword in front. So you cannot say public, int get total. Okay. Or can you? I thought you can. Why you can? Contains only constant and abstract methods. I'm surprised this one can have it. Usually you can't.
So you can try to compile it.
Yeah, maybe you compile it. It might not run it. But it should throw an error. Let's see. Quickly, I can just say. And also the difference between if you have a interface, if you want to inherit that, you cannot use the keyword extends. It has to be the keyword implements. Okay, that's another one different thing about interface, geometric shape.
So, were you saying interfaces should be used for something that has a broader scope.
Yeah, it has like just functions and data fields to be used.
Right. So
Okay,
like
that's all
if
it
you
has.
wanted to go broader than an abstract class, then you would want to go with an interface.
Mm-hmm.
Or think about it at least.
Yes. So you could, if you think about like the maybe the vehicle a little bit better. Like you could think of like transportation. That could be like really broad. You know, and then you have what do you have like I don't know, motion, move, whatever it is. And then you have the vehicle, which is a part of that transportation class. And then you have the cars going to the vehicle. So that transportation or that method has all these features that can be shared throughout all the other subclasses. Okay, so yeah, but I don't know. I'm not sure why. I thought you would have to have the abstract in front, but I guess you don't have to, or unless you do have until like John was saying, maybe until you run the application. Okay, but anyways, so when you implement the abstract, the interface, you have to use the keyword implements instead of the extends. Okay, so
Can you do both?
yes, you can do both. You can extend a class and implement an interface. So I could have like extend the shape and implement the geometric shape. Okay, you can do both. Has some issue here, but yeah, you can do you can extend an abstract or a concrete class, but the implement you can only do one, right? You cannot do like, for example, I cannot do triangle, and then a rectangle like that. You cannot do more than two. I mean more than one, right? For the extend. But with the implementations, you can implement as many interfaces as you want. It's fine. So if you only implement geometric shape, if you want to have another one, you put G2 here, G3. It doesn't matter how many more you can have. You can implement a lot of kinds of interfaces in here. Okay, so but typically interface contains only public data like fields and methods. And because it's so common, it's already known that way, you don't have to put this in here. You have to put this part or even the public part here, or even maybe even all this. Okay, it's understood. I mean, that's why it worked. Okay, you don't have to put that there. It just knows that these are abstract methods and these are final. Okay, so yeah. So now it doesn't like it because I have to implement those two methods. I have to implement the total here. But take that out, and it's happy now. So it's extending the geometric shape, which is the interface, and this is a string name with the constant. Even though I don't put these final in front of it, usually final means constant. You can't change the data, right? So in other words, I cannot go in here and say no geometric shape dot name is equal to John. Okay, right? It says you cannot change a field that is final, even though in the interface I don't say final here. Okay, you don't have to say explicitly. It's understood. It's known that it has a final. And so it's already public final. And same thing here. So even though I don't put abstract in here, as you can see, it asks me to has an error because I have to implement that method. So this method here has to be implemented inside this class from here. It's an abstract. You just don't see it. Okay, so that is for that chapter, and I have one assignment inside, I think chapter 13, the number 1 and number 2, forgot which one. It's a really, hopefully it's a simple one. So see how far you get to that exercise. It's a really, should be a short one, and that's the only one. And you have time, read over chapter 14, and next week we'll come here, we'll start diving into Java FX. Okay, from there on, it's all GUI now. Okay, so this is the last, the only one that it's not has the GUI interface. Okay, thank you. We'll see you next week.